Question number 4. All the light bulbs in this circuit are lit. Which change could cause all the bulbs to go out? So our question here is, which change would cause all the light bulbs to go out? Okay, right now they're telling us that all of these are lit, meaning they are on. They are working, all right? So if we look at our answer choices and we look at our picture, we see that the wires must start at one end of the battery, run all the way through, and come all the way back. You have to have the flow of electricity leave one end of the battery and come all the way back through so that you have that continuous cycle in order for it to be a complete circuit. So all of these are on. So this is on, and this picture is a picture of a complete circuit, okay? Which change would cause all of the light bulbs to go out? Going out also means be off, okay? So it says removing wire 1. If we remove wire 1, will that cause all of the light bulbs to go out? Well, let's look at it. If we cross out this one right here, let's say we start here at the positive end. It doesn't matter if you start at the positive or negative for the sake of this picture. You just need to start at one end, go all the way through, and come all the way back. So say we started here. Could the electricity flow all the way here, up through the light bulb on the filament, out, and either on this path or this path, up through the filament and out, and then this path, up through the filament and out, and then back in? Well, it can't flow back in. So the electricity cannot get from positive to negative end. Okay, so that means that the light bulbs would not be working. They would all be off in that case. So this might actually be our answer choice. But we always have to make sure that we are going and checking all of these answer choices. Let's look at G, removing wires 2 and 4. So if we remove this wire right here, take this one out, and take this one out, well, if you look, these two wires are really serving the same purpose. They're connecting this light bulb to this light bulb. And these two wires are both connecting this light bulb to this light bulb. So as long as we have one of them, we still have a complete path. If this one were there, we would still be able to get all the way back through by just getting rid of 2 and 4. So that would, let's see, I'm going to draw a little line over here. All lights would be lit. And that's not what they want. So that would not be the correct answer. H, remove wires 2 and 5. Well, here's 2. We already talked about that. 5, if we kept 4 and removed 5, then it would be the same thing. We would still have 4 to connect this light bulb to this light bulb. So all lights would be lit. Okay, so that's incorrect. Removing wires 3 and 4. Oh, goodness. Friends, just like we talked about, as long as you have wire 5, okay, we took it away in the last one, but we would still have wire 5 and wire 2, so the flow of electricity would still be able to pass through. So, all lights would be lit. So that is incorrect. So your correct answer is F. If you remove this wire right here, the electricity will not be able to flow out one end of the battery and all the way back through. Out one end of the battery and all the way back through, it would be impossible. Therefore, cutting and removing wire 1 would make this an incomplete circuit, and since all of these light bulbs are hooked together on one series circuit, they would all go out. If one goes out, they would all go out, because this one can't be lit unless this electricity goes all the way through the circuit. So your correct answer choice is F.